Lesson 3. Current limitations with batch and continuous fermentation tests. Although the two methodologies presented in Lesson 2 show significant potential in helping researchers accomplish their characterization objectives, there are a number of limiting factors that compromise their usability. Let's take a closer look at the challenges you may encounter as a researcher. The lack of standardization. Batch and continuous fermentation tests suffer from a lack of standardization, not just at the test procedure level, but also when it comes to the way results are presented. There are many different protocols out there, and it's pretty common for researchers to adjust the existing protocols to their own specific needs. In that context, how can you benchmark your tests against the others? Let's take a look at a specific example. The volume of a gas depends on its temperature and pressure. When studying gas volume, it is vital to consider and accurately report both of these parameters. Still, researchers today might simply assume a pressure or temperature measurement. Alternatively, they might just take a spot measurement. The problem with this approach is that over the course of time, the temperature and pressure may vary significantly, resulting in an inaccurate gas volume measurement. Self-developed and varying lab setups. Today, most batch and continuous tests are performed with lab setups that have been built and designed from scratch by scientists or laboratory technicians. Typically, these self-developed lab setups are not user-friendly and leave room to uncertainty in recorded results due to lack of standardization and because too little time was invested validating the system. Once again, it makes it difficult to compare test results within the researcher community. Manual and varying techniques for gas sampling and analysis. Just like with equipment, solutions for analytical measurements vary greatly. This is particularly true for measuring gas, which can be difficult due to the frequent low flow rates. At lab scale, gas flow rates can be less than 100 milliliters per day, and a lack of conventional flow meters in this range drives researchers to develop their own solutions to determine the gas volumes. This then leads to large variations in results and data quality. Another issue is that most of these methods are manually operated, which leaves room for human error. In addition to this, measurements can only be taken when an operator is present. This leads to limited data sets in quality and quantity. There is also a high chance that important kinetic information about the degradation process is lost because measurements are not taken often enough at variable time intervals. The human factor. Traditionally, many of the tasks involved in batch and continuous fermentation tests involve manual operations. This means that the lab worker needs to show a sufficient level of skills and experience. If not enough attention is put into the operation, results can be unreliable and difficult to use for benchmarks. The procedures are time-consuming and labor-intensive. The high number of manual activities leads to tests that are time-consuming and labor-intensive for the lab worker. This, in turn, increases the cost of the test procedure, thereby limiting the number of tests that can be performed. Conclusion. The limiting factors we just covered here lead to one main conclusion. Inaccurate results are difficult to compare. This is actually quite an issue. It's not uncommon to see large variations and contradicting results when looking through the scientific literature. Tests often have to be repeated to ensure more reliable results. In order to advance our research further, the key is to reduce the time and effort spent on batch and continuous tests, reduce the room for error, and produce more reliable, accurate results. How can this be achieved? In Lesson 4, we introduce you to 3 solutions that can fully address these limitations for the benefits of your operations.